Hello everyone. In this video, I'm going to go over some of the questions from the test 2 practice questions. So for this test, there's going to be two parts, reading code and writing code. And it's very important that you understand the right way to answer the questions. So in the reading code part, for every question, all you have to do is write down what is going to print out when the program runs. So I'm going to give you a box with lines. It's going to look something like this. So you'll have a box that has the code in it, and then you'll have a box with lines, and you can put any notes or scratch work on the question itself or in the margins. But in the lined box where I'm asking you what is going to print out, only put the things that Python would print out when it runs the code there. Do not put anything else. Okay. The only exception, I guess, is if there's going to be an error, you can just write error. You don't need to know like what the whole error message would look like. So it's very important that you don't put any scratch work in your lined box where the things that Python will print out should go. Okay, so other than that, you're just going to pretend like you're Python and print things out exactly like Python would do. So it could be like on one line or more than one line. I'll give you more lines usually than what you would need, just because I don't want to give away like how many lines exactly you need. So let's go ahead and go through these practice questions, and I will show you how to do them. So the first part, 1A, is while loops with string indexing and slicing. Okay, so the first question here, we are given that n is assigned to have the value 37, and then we have a while loop. So what I'm going to do is, and this is also what I would suggest that you guys do on the actual test, is I'm going to make notes to myself on every single one of these lines here about any values that are being assigned or any conditions that are being evaluated. So I'm going to go ahead and make a note here that of what the truth value of this first condition is. So the condition while n greater than 0. So when n is 37, n is greater than 0. So this is going to start off, and I'm going to use comments to do it, but on the real test, you can just use your pencil. That is going to start off as true. Okay, and then I'm going to do the same thing here with this if condition. So remember, n%2, that is the remainder after division by 2. So remainder of 37 after we divide by 2 would be 1. So that is not equal to 0. Okay, so this would be false, which means we would come down here and we would do the else code instead. So the first thing that's going to happen here is we're going to print off a 1. So now underneath of all of this, I'm just going to make a little area where, I don't know what I should call this, like printed stuff. There we go. So I'm going to make notes of like what is going to print out. So the first thing that's going to print out is this 1 right here. And then n is going to be assigned to become n minus 1 divided by 2. But remember here with the double slash, that is integer division. So basically it's like regular division, except you round down to the next integer. Or another way to think of it is it's that integer quotient that you get when you're doing long division. So it's the number of times that 2 would go into n minus 1 as a whole number. So n minus 1 would be 36, right? And 2 goes into 36 18 times. So this is going to make n become 18. So that is the new value of n, and you must keep track of that for running the next iteration of the loop, because now we're going to come back up. Every time with a while loop, you come back up to the top and you check the condition again to see if it is still true. And so now this is still true. And what I want to then do is go ahead and I'll just make a note here like that it's still true. On the real test, maybe you can use like strike through to cross off previous values and replace them with new ones. But I'll just use commas to do this. Now I'm going to check this condition again. So n is currently 18. Remainder of 18 divided by 2 is going to be 0. So now this is true. So I'm going to go ahead and do this code here in the if block. So I'm going to print a 0. So I put that down here. And then I'm going to assign n the new value of n divided by 2. And since n is even, I don't really have to worry about rounding down. This is just going to be 9. So that is the new value of n. Okay, and I don't know, I can't really do strike through on, Or can I? Hold on. Okay, I just paused the camera and did like a way too long research on whether there was a way to do strike through. I think there's not like a great way for me to indicate strike through on the code here, so I'm just going to erase when I make a new value for n. I'll just erase the old one so it doesn't get visually confusing. When you're doing it on your test, you can just like cross off the old values for n and replace them with new ones. Okay. So currently we have that n is equal to 9, and that is the end of the if block, and we're skipping over the else block. So we're going to go back to the top here and check if this condition is still true. And when n is 9, it is still true. So then we're going to come to the if condition here. We'll check this again. So 9% 2 is going to be 1, so that is not equal to 0. So this is going to be false. So we're going to come down here and do the else block. So we're going to print 1, and then we're going to assign n the new value of n minus 1, so that's 8 divided by 2, which is 4. Okay, so n now has the value of 4, so I'm going to erase this old value. Okay, then we come back to the top of the loop. Check, is n still greater than 0? Yes, it is. So that is true. We're going to check n% 2, so remainder of dividing 4 by 2 is 0, so it does equal 0. So this is true. So we're going to do this block. We're going to print 0. And then we're going to reassign n the new value of n divided by 2. So 4 divided by 2 is going to be 2. So I'll erase the old value of n. And now we come back up to the top. Check, is n still greater than 0? Yes, it is. So we're going to check this part again. N remainder after dividing by 2. That is going to be 0 this time. So it is an even number. So we're going to do this code block again. So we print another 0, and then we're assigning n the new value of 2 divided by 2, which is 1. Okay, now we come back up to the top of the while loop. Check, is n still greater than 0? Yes, it is. We do 1% 2, remainder after dividing 1 by 2 is 1, not 0. So this is false. So we're going to come down and do the else block. So we're going to print 1. And then we're going to assign n the new value of 1 divided by 1, or sorry, 1 minus 1, which is 0, divided by 2. So n is going to get the new value of 0. And I'll erase the old value. And so at this point, finally, when we come back to the top of the while loop here, we're going to check this condition, and now it is finally going to be false. And so at this point, we are done with the while loop, and we're done with this code. So I think I'm going to go ahead and erase my notes here, just because I feel like this could be fairly confusing if anyone's looking at these solutions kind of after the fact, because I erased all these intermediate values of n. I'll just leave this printed stuff here, and let's check it against the actual printout here. Make sure we did this right. Yeah, 101.001. So interesting thing about this code is it's actually printing the binary version of 37, starting from the least significant ones digit. This is the twos digit, the 4s, 8s, 16s, and 32s digits. So that is kind of fun. All right, let's look at the next one. So we have two numbers here. Large and small are the names of the variables. And we're doing another while loop. And we are checking for the condition of the while loop, while small is greater than 0. So clearly that does start off as true for the first time. And now we're assigning a new variable. New small is given the value of large percent small. So we're doing the remainder after dividing large by small. So if I divide large by small here with these original values, small goes into large one time, and then it's going to leave a remainder of 93. So new small starts off with the value of 93. And then I'm assigning large the new value of whatever small is. So large gets the value 102 currently. And then small is assigned the value of new small. That was the point of calling it new small. So small is assigned to be 93. Okay, and then I am printing out large, comma, small. So down here in the printed stuff area, the first thing that's going to print out is large, comma, small. So that's going to be 102, 93. Remember, putting a comma between these means it puts a space between them down here. Okay, so now we come back to the top of the while loop and we check, is small still greater than 0? Currently small is 93, so that is true. Okay, and now I'm going to assign, on this next line here, I'm assigning new small a new value. So I'm going to put a comma here, and I'll just put what the new value is rather than maybe erasing the old one. That way I can have a record of what I was doing. That might be a little nicer for people to look at when they're looking at these solutions. Okay, but I'm still doing large percent small. So right now large is 102. I'm going to actually write down these numbers. And then small is 93. So the next value for new small is going to be 102% 92. So we're doing remainder of 102 divided by 92. 92 goes into 102 once, and it's going to really leave a remainder of 10. So that is the next value for new small. Okay, and then large is assigned the value of small, which currently is down here, 93. Okay, and then small is assigned the value of new small, which is currently 10. So small is going to become 10. So I'm just going to kind of keep track of what these three variables are on these three lines here, because they each are only assigned on one line each here. So I'll use the listing over here to kind of keep track of their values. Okay, and so now I'm going to print large, comma, small, and currently my large is 93, small is 10. So I'm going to print 93, 10. Okay, then I come back to the top, check, is small still greater than 0? Small is 10, so yes, it is. And again, I'm just going to go through this assignment process. I'm assigning new small to be large percent small. Large is currently here, 93. Small is currently here, it's 10. So I'm doing 93% 10. That is going to come out to be 3. It's 10 goes into 93 9 times and leaves a remainder of 3. Okay, now large is assigned to be small, which is currently 10. Small is assigned to be new small, which is currently 3. And now we're printing out large small, which is 10, 3. Okay, come back up to the top. Small is still greater than 0, so this is true. So we're going to do it again. New small is going to get the value large percent small, so that's going to be 10% 3. 10% 3, that is going to be 1. Large is assigned the value of small, which is currently 3. Small is assigned the value of new small, which is currently 1. And then we print out large small, which is 3, 1. Just keep doing this process. I think this is going to be the last time because small has gotten all the way down to 1. So we check one more time up here. Is small greater than 0? Yes, because it's 1. And now we're doing new small, large percent small. So we're doing, let's see, large is currently 3, small is currently 1. So 3% 1 is going to be 0. Okay, because 1 goes into 3 times and leaves no remainder. Okay, so then large is assigned to be small, which is 1. Small is assigned to be new small, which is 0. We print out large small, which is going to be a 1, 0. And then we check again, is small greater than 0? And now it is not. So this condition is false, and that means we stop. Let's go ahead and run this, make sure it's correct. Let's see, what did I do wrong? Oh, I see what I did wrong. I put 92 here instead of 93. I guess I just copied that down wrong. So this should have been, okay, so that was on the second go around. So basically I need to back all the way up to like here. And that should have been 93. So only the, oopsie. Okay, so that value was wrong. It was, okay. And then, all right, so when I was on the second go around, I see, I should have done 102% 93. That should have been 9. And then this would have become, so large would have become small. Woo. I think I have to redo the whole thing. Gosh, I don't think I can back up in time that easily. Okay, I'm going to pause the video and redo it. Basically, like, the process that I showed you guys was correct, except for just an arithmetic mistake. But, like, the thinking part was fine. So I'll just pause this and fix it. Okay, so there I fixed all the numbers and stuff. So just as a point of interest, it doesn't really matter for this test, but this algorithm calculates the greatest common denominator of two numbers. So the last number that you see before 0 is the GCD. Okay, anyway, moving along. Next while loop. So we're given two initial values here. X is 18, Y is 0. And okay, so we are going to start by checking this condition here. We check whether Y is less than X. So to start off with, Y is 0 and X is 18, so this is true. Okay, and now we're going to do the code inside the loop. So Y is going to be assigned the value of Y plus 1. So basically Y is going to become 1. And then we check whether this is true. Is X% Y equal to 0? So right now we're checking X is 18 and Y is 1. So X% Y is going to be 0 right now. So this is going to be true. Yeah, so I'm just going to put this like as a little note here. Like, this is the calculation that I'm doing to check that this is true. So 1 goes into 18 evenly with no remainder left over. So then I am going to go ahead and do this print line right here. So let's write printed stuff down here. So things that we're going to print out are first Y, which is currently 1, then a star symbol. And remember, when there's a comma between here, unless you changed the optional sep argument to change the separator, you by default will print out a space. Okay, and then the star. And then there's a comma, so another space. And now whatever X/Y was. So this is going to be, let me just make a note over here. What is it? 18/1, that's going to be 18. So this is going to print out 18. Okay, so now we finished all the code here. So we go back to the top of the while loop and we check, is Y still less than X? So we're checking whether 1 now is less than 18. And that is true. So we're going to assign Y to be Y plus 1. So Y is going to be 2 now. Okay, and again, we check whether X% Y is equal to 0. So X% Y this time is going to be, so it looks like X always stays the same, right? So 18, and we're doing %2. And that does go in evenly, so there's not going to be any remainder from 18 divided by 2. So this is going to be true. So I am going to do this print command again. So I'm going to be printing out, now it's going to be on a new line. So first I'm printing Y, which is 2, space, star, space, and then this X/Y here. I'm just going to make a little note to myself over here. This is about what the value is. I think this is 9, right? Okay, so after you see the first couple lines print out, you maybe start to get the idea of like what this code is doing. It is factoring 18 into like different factors. Okay, so we finished that. We're going to go back up to the top, check, is this still true? Is Y less than X? Y is 2. So yeah, it is still less than 18. Y takes the next value, which is 3. We check whether 18% 3 is equal to 0, and 18% 3, yes, it does divide evenly into 18 again. So this is 0, so that is true. So we're going to print again. Now I think maybe I can do this a little bit faster. So it's going to be 3 for Y, and then the star, and then 18 divided by 3 is going to be 6. So once you kind of got the idea of what's happening here, maybe you can like do the next ones a little bit faster. But let's go ahead and do a couple more at least. So I'm going to go back to the top. I'm going to check again, is Y less than X? So 3 is less than 18. Yes, so that is true. So next value for Y is going to be assigned 4. And now for the first time here, I think we get one that is false, right? Because 18% 4 is not 0. 18% 4, it goes in 4 times, and then you have 2 left over. So this is going to be false. It's not 0. So we do not print anything in that case. So in that case, we just go back to the top, check is y still less than x, is 4 less than 18, yes. So we go to the next value here, and I'm just going to go ahead and do the next calculation here. So 18% 5 is going to be 3, which is not 0. So we get another, so I have to move my like hidden screens here. Okay, so we move, we evaluate that as false. So we are not doing a print, and we're just going to come back to the top of the code, check is y still less than x, 5 is less than 18, so this is true. Okay, and now we go to the next value for y, which is going to be 6. Okay, and now finally we're going to get one that's true again, right? Hopefully you guys can see how this is working. So 18% 6 is going to be, that is going to be a remainder of 0. So we are going to go ahead and do this print line here. So we're going to print current value of y, which is 6, star, x divided by y, so 18 divided by 6 with the double slash is going to be 3. And once you look at this for a while, like I think hopefully you can do the rest of it mostly without like needing to write it all out. So I'm just going to pause the video and like speed up a little bit until I get to the end. Okay, I said I was going to like pause it into it, but I actually even think that's like too time consuming. I'm just going to go ahead and put in the next ones. So you see here what's happening is y is increasing by 1 every time. And then when y divides x evenly, we basically are like factoring 18 into y times the other factor that makes 18. So the next one that's going to print out is going to be 9. And then we're going to have 2 over here because that makes 18. The next number that divides into 18 evenly, so not 10, not 11, not 12, not 13, not 14, not 15, not 16, not 17. Okay, so 18 is actually going to be the last one. So I think what's going to happen is when y is 17, this will be the last time that 17 is going to be less than 18. And then we get to y being 18. And then we are doing 18% 18. We're checking if that's 0, and it is. Okay, so we come down here, we do the print, and we're printing 18 double slash 18. So we're going to be printing 1 for this part and 18 for this part. So 18 star 1 like that. And that, then we're going to go back up to the top. And when y is 18, this is finally going to be false. Okay, so the very last time it runs, when y is 18, it'll be false. And that'll be the last time. So basically we just factored 18 into all possible pairs of factors that it could have. All right, so that's the last one for this section. And let's go ahead and look at part 1b, which is string indexing and slicing. It's a little bit different topic here, but we're still looking at some while loops because they're pretty important, but we also have a for loop here to practice on as well. So for the first question, t is the string wherever, and while e is in t. So the first time that this runs, t is wherever, and we just check if this condition is true, and it is going to be true because e is in wherever. So when we're checking e in wherever, this is going to be true. So that's the first time it runs. Then we're running t.find e. So remember, when whatever you're looking for is actually in the string, that is going to return the index of where it's at. So we're going to the t string, and we are finding where e is from the left. So it's going to be 0, 1, 2 is the index. So 2 is going to be assigned to I. So I is going to start off as 2. Okay. And then it looks like we're reassigning t to have a new value. So we're replacing t with these 2 string slices. So the first slice here goes from the beginning of t, and then it stops before the ith index. So what's happening here is the first slice is starting at the beginning, so w, h, and then it's stopping before the 2 index. So remember, you always stop 1 before the second part. And then we're concatenating or gluing that to a second slice. The second slice starts at I plus 1, which is 3. So we're starting at the 3 index, which is the R. Okay, and then because there's no number after the colon, it just goes to the end of the string. So what's happening here is these are the two slices that we're gluing together. So the new value for t is going to be wherever. So we basically just deleted the e. Okay, and then that is getting printed out. So printed stuff list down here. The first thing is, oopsie. Oh, I should have checked these up here too, shouldn't I? I forgot to check this one. Yeah. Anyway, right, so the first thing that's going to get printed out is this wherever. Okay. Now, since we finished the code inside of the while, we come back to the top of the while loop and we check the condition again. But now what we're checking is the character E in the new value of t, which is this wherever. So we're checking a little bit different thing this time, but this is still true. E is still in there. And so now we're going to be finding E from the left, and we're finding it in this wherever string. So the index where E is 0, 1, 2, 3. So I is going to be 3. And then basically what's happening down here, we're just doing like the same thing we did before. We're just slicing around where that E is. We're going from the left and we're stopping one before the index where the E was. And then we're including everything from one after the index where the E was. So pretty much all that's happening on this line is you're always just slicing out that first E on the left. So I don't really need to think like super hard about counting and stuff once you realize that that was the point of what's being done here. So that is the next thing that's going to get printed out. And then we're going to come back to the top, check this condition again. Is E still in T? So now the value for T is this wherever, but it does still have an E in it. So this is going to be true. Okay, so we are going to run the while loop again. We're going to find the value, or we're going to find the index of E. So currently E is at 0, 1, 2, 3, 4. Okay, and we're going to slice up to before where the E is, and then everything after the E. So T is going to become wherever. And we're going to print that out. And that's pretty much it. Because at this point, when we come back to the top, E in T, now we have a string that has no E's in it, so E in T is going to become false. So this is false. And we stop. And that's it. Okay, so let's look at the next question. I'll just go ahead and run this and make sure. Yep. Okay, so string S is assigned to be computers. While the length of S is greater than 0, we print S, and then we replace S with this slice. Okay, so I can already see here when S is computers, so we're checking whether len of this is greater than 0. The len of that is 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9, which is greater than 0. Okay, so that is going to start off as true. And then we're going to go ahead and print S. Okay, so printed stuff. Put it down here. So we're printing computers, first of all. All right, and then we are assigning S this new value here. So we're slicing into S. We're starting from index 1, which is going to be the O. And then what you have to understand here, remember that -1 refers to the last character, but we always stop 1 before the second number here. So we're starting from the O, and we're stopping 1 before the last character. So basically we're taking the center and we're cutting off the first and last character. So S is going to become omputer. My fingers didn't want to type omputer because it sounded wrong. Okay, so now S is omputer. And we come back up to the top. Check is the length still greater than 0. So for the second check here, we're looking at the len of this string, which is 1, 2, 3, 4, 5, 6, 7. So that is greater than 0. Yes, so this is true. So we're going to print again, and now we are printing omputer. And then again, we're going to assign S the new value of, well, we're just doing the same thing we did before. We're slicing out the middle. So from the index 1 character, which is M now, to 1 before the end, which is E. So impute. And then we come back up to the top. We check is the len greater than 0. So I'm not going to keep like typing out the whole check that I'm doing here. It's 5 this time. You can hopefully see, which is greater than 0. Okay, so we're printing out the current value of s. So it's cute. Oops, my fingers just want to type it correctly. Okay, and now we're assigning s new value of put. Okay, and we check, is the length still greater than 0? Yes. Printing it out, so we're printing put. And now assigning s to be just the center part, not including first and last, so u. And come back up to the top. Is the length greater than 0? Yep, length is 1, still greater than 0. Okay, and we're printing out what s is, so we're just printing that u. And now for the very last slice here, it does get like a little bit weird at this point, so the slice kind of stops making sense. But if you guys recall how slices work, you can do all kinds of slices that don't make sense, and you basically just get an empty string when you do that. So we're going to get an empty string here. So this s here is just going to be an empty string, and then what's going to happen is when we come back up to the top and we check len of s, it is actually going to be 0 this time. So what's going to happen is when we get the empty string here, this is going to be 0, which is not greater than 0. So that's going to be a false check there, and we're done. So let's go ahead and run it, make sure. Yep. Alrighty. So moving to the next one. I'm sorry, I just like was looking at this for a second. I was like, did I give the exact same one? But no, this is actually like subtly different in a way that is kind of weird. Okay, so s is going to start off as the string hawks, as in our school mascot. And now we are doing a for loop, not a while loop. So we're just going to go through the values 0, 1, 2, 3, 4 for I. Okay, so I is going to start off as 0. Go ahead and make a note of that. And so the first reassigned value for s here is going to be, let me actually type out what this is until it like makes sense that I can figure it out in my head. So we're going to start at 0 and then go to the end. Okay, so that's everything. That's the entire hawk string. And then for the second part here, it's going to be s bracket. So it's everything from the beginning to I plus 1, which is 1. Okay, so this is a little bit weird, but like this first slice here, that is going to start from the 0 index and go all the way to the end. So that's going to be the entirety of hawks. And then the second slice here is going to start from the beginning and it's going to stop 1 before the index 1. So basically you only get index 0 from that, which is just the h. So altogether here we're going to get hawks for s. And then we're just going to print that out. So printed stuff here is hawks. All right, and then we come back to the top and we're not checking anything. We're just going to the next value of I, which is going to be 1. Okay, so here I'm gonna have to make some like more lines to give me room to parse this out because it is a little bit weird. So s is going to be assigned the new value of, so it's going to start at 1 and go to the end. And then we're also going to do everything from the beginning up through 2. So the weird thing is now we have this new value for s to work with. So we're starting at the 1 index here and going to the end. That's this ox part. Sorry. And then for the second slice here, it's everything from the beginning and then stopping right before the 2 index. So it's going to be the 0 index character and the 1 index character. So HA. Okay. And so gluing those together, we're going to get just ox and then HA. So it is kind of just like mixing up the letters in hawks and like putting some extra ones. Did not mean to do that. Okay, so the next thing that's getting printed out is this next value here. I think I'm going to go to a new line below this and put more comments there. Okay, so the next value for I then is going to be 2. And so S is going to become, so we're going to be slicing from 2 until the end, plus slicing everything from the beginning until 3. Okay, so I think I'm starting to like kind of get an idea of what's happening here, but it's still pretty weird. So I think I have to just keep typing it out really carefully until the end because it doesn't seem very sensical, I guess. Is that a word? Sensical? All right, so everything from the 2 index until the end is going to be, okay, so 0, 1, 2. So that's KSHHA. I'm really asking myself what mad woman devised this problem. Oh no, it was me. Okay, and then everything from the beginning until before the 3 index, so basically 0, 1, 2, so the AWK. Alright, and we're just gluing those together. So this is, I'm just gonna copy and paste them both in here. Okay, kashok. Sounds like a noise a hawk might make. All right, we come back up to the top. We're doing I equals 3. Oops, 3. Okay, so S is going to be the slice from 3 until the end, plus the slice from beginning until 3. So we're going to take everything from 0, 1, 2, 3. So starting from the second H here until the end, and then plus the 0, 1, and 2 indexes. So wait a minute. Oh, sorry, I did my math wrong here. This is supposed to be 4, right? It's I plus 1. Yeah, so this is going to be the 0, 1, and 2, and 3 indexes. So 0, 1, 2, 3. All right, so like that. And getting... Oh, I forgot to put my printouts at some point. We were supposed to be putting these under the printed stuff, right? So, oops. What did I do there? Yeah, so we're supposed to put that one. And then the one that we just did. Hawksh. Okay, and then there's going to be one more because we have to do I equals 4. Thankfully, that's the last one. Okay, so S is going to be S slicing from 4 until the end, plus S from the beginning until 5. Okay, so 4 until the end is going to be, let's see, 0, 1, 2, 3, 4. So all of that. And then beginning until 5, so we're going to stop at 4. So 0, 1, 2, 3, 4. So that. And we're just gluing those together into one string, which is what is going to print. And we got some nonsense. I wonder what I was trying to do with this problem. I wonder what I was thinking. Okay. Let's see if we did this right. Yeah, we did it right. Okay, some nonsense. All right. Well, let's look at the next problem. So we have 2 strings, S1 cat and S2 bird. And it looks like first we have to calculate the minimum of their lengths. So their lengths are 3 and 4, and the minimum of those is 3. So the shorter one is going to be 3. So N is going to start S3. And then S3 is an empty string, which already right away tells me we're probably doing accumulator pattern, and we're probably going to try to build up S3 one character at a time, or maybe one slice at a time. So now we're doing a loop for I in range N. So N is 3, so I is going to go through 0, 1, 2. So I is going to start as 0. And S3 is defined as, okay, so this is a weird accumulator pattern, but you see S3 is here in the middle. So we're gluing something to the front of S3 and to the back of S3. So we're gluing the ith character of S1 to the front, and we're gluing the ith character of S2 to the back. So S3 is going to become the following. So S1 bracket 0, okay, plus S3, which is currently nothing, it's empty, plus S2 bracket 0. So right now, S1 bracket 0 is going to be C, S2 bracket 0 is going to be B. Okay, and then S3 is just empty string. So this is the first gluing that we're doing here. It's C plus empty string plus B. So we get CB. All right, and then we are printing that out. So for printed stuff here, first thing that prints is CB. Okay, then we go back to the top of the loop. Next value of I is going to be 1. Okay, so I'm going to go to another comment here and do it below. So next value of S3, we're going to do S3 equals S1 bracket 1, because that's the value of I, plus S3 plus S2 bracket 1. Okay, so S1 bracket 1 is the one index of S1 is A, the one index of S2 is I. So this is going to be A plus current value of S3 is CB plus S2 bracket 1 is I. Okay, so we are going to get A, C, B, I. All right, and then we're going to print that out. So A, C, B, I. And then the last time this runs, I is going to be 2 because we're going range 3, which stops right before 3. Okay, so last assignment for S3 is going to be S1 bracket 2 plus S3 plus S2 bracket 2. So the index 2 character of S1 is T. We're adding that to current value of S3, which is ACBI. And then plus the index 2 character of S2, which is this R right here. All right, so just gluing all that together, we get TACBIR. Now you can kind of like make out what's happening here. We're basically building up S3 to be S2 forwards with S1 backwards in front. It's a little bit weird, but not as weird as the last one. So, so we get TACBIR. And that is the last thing that prints because we've gone through the whole range at this point. Okay, so last question in this section is dealing with messages and ciphers. So we have X, which looks like an alphabet, and Y looks like a scrambled alphabet, which I think it is, if I remember my own mind correctly. And then we have a message, which is hello, and a cipher string, which starts out empty. So I guess we're going to build up the cipher string. Yeah, looks like that is what we're doing. So 4-letter in message. Okay, so now we're looping through these 5 letters here, H-E-L-L-O. So the first value that letter is going to have is H. Okay, then what we do is N is going to be X.find letter. So we go to X and we find letter, which is H. So there it is right there. And we're getting the index for that character. So this is index, let's see, 0, 1, 2, 3, 4, 5, 6, 7. So N is going to start off as 7. Okay, and then for cipher, we are going to add on to the end of cipher. So it's going to be that original value of current value of cipher, which is empty string, plus Y bracket 7 is the current value of N. So Y bracket 7 is going to be 0, 1, 2, 3, 4, 5, 6, 7. So you see what happens here is basically we just look between these two strings here. If I had H before, then I'm putting K instead. So this is going to be empty string plus K. In other words, just K. And then I'm printing out the current value of cipher. So down here for printed stuff. Oops. Oh, I should have been checking that on the last one too, sorry. The first thing that's going to print is the K. And go back and check this one. Yeah. Okay, so once you kind of understood how it works, you're basically just doing that for all the letters in message. So the next value for letter is going to be the E. And we're going to go, I don't know what number it's going to be, but I'll just put a little etc. here. We're going to find E in the alphabet string. And then the letter that we're adding to cipher is Y at that same index. So it's going to be this P down here. Okay, so the next value we're going to get is P, and we're going to add that to the end of cipher. So we get KP. And then for the L, we're going to find it. Here it is. And we're going to find the letter at the same index in Y and add that to the end of cipher, which is a U. So it's going to be KPU. And then we're going to do that again for the next L, of course. Okay, so it's going to be KPUU. This will be KPUU. And then the last one is the O. So the O is here, and we're going to replace that, or we're going to add the I to the end of the cipher. So KPUUI. And we're printing that out. And at that point, we've gone through all the letters in message, so we should be done. Yep. Okay. Okay, so the next part 1C, string methods. This is the methods that you call with dots, including upper, lower, count, find, split, replace, and is alpha. So we did actually use find in the last one, so maybe I should have put that in this section. But anyway, let's go ahead and try these. So we have two strings here. X is National Collegiate Athletic Association, and then Z is an empty string. So we're probably building up Z. And we're going for Y in X. So Y is going to become each character in X one by one. As you can see, we're going to have a lot of repetitions of this loop because there's a lot of characters. But we're going to start off with the first value for Y is going to be that capital N at the beginning. And then we're checking this condition here. So if Y dot is upper, so we're checking whether this letter here is uppercase. And it is for this first letter, so that's going to be true. So then we're going to go ahead and we're going to add Y to Z. So Z is going to become whatever it currently is, which is empty, plus Y, which is N. So for the first value for Z here, after empty string, we get N. And then we're just printing out Z. Okay, so printed stuff, first thing is the current value of Z, which is N. All right, then we go back to the top. We do the next value for Y. So next value for Y is the next letter, which is lowercase a. And then we check, is that lowercase a uppercase? And it is not. So in that case, we're not printing anything. And I'm basically just going to like skip ahead. So we're just going to get a bunch of falses until we get to the next uppercase character. And then that is going to get added to Z. Okay, does that make sense to you guys? So if the letter that you're looking at is not uppercase, you don't print anything and you don't add anything to Z. So the only times when that letter is getting added to Z is when it was uppercase. So hopefully you guys can see that basically you're adding one uppercase letter at a time to Z as you come to it. And every time you add one letter, you're then printing the new value of Z. Okay, so in terms of what's getting printed out here, it's going to be NC and then NCA and then NCAA. Oops, just two A's. So I'm just going to put etc. here for these, but hopefully you guys are able to figure out that pattern. And there it is. Okay. All right. So looking at the next one, we have a string called r www.suscu.edu. And then S is defined to be the same thing as R. Okay, that's interesting. And then for T in R, so T is going to go through the letters in R, or the characters in R rather, one by one. So first value for T is going to be this first letter W. All right, and then we're checking if not T dot is alpha. So basically, if the character T is not alphabetical, if it's not a letter of the alphabet, then we're doing some stuff. So nothing's going to happen right away because T is alphabetical for the first few letters. So when we have W, 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 this is going to be false. So this is going to be like false, false, false. And it's not until we get to the period that something's going to happen. So when we get to the period for T, then finally this becomes true. So it's true that T is not alphabetical. All right, and then we get to actually do something. So S is going to be redefined as S.replace, and we're going to replace T with a space. So what happens when you call this replace method is it's going to replace everywhere that it finds whatever T was. So in this case, T is the dot. So it's going to replace all of those dots with whatever is here, which is a space. Okay, so S is going to become www space suscu space edu / All right, and that's going to be the new value for S, and then we are printing that out. So in the printed stuff area here, the first thing that prints is www CSCI-181-24SP/. Okay, and then we're going to come back up to the top, and I'm just going to skip ahead. So the next thing that we get to is we actually get to the dot again, which is interesting. So when we get to the dot again, this is the next time anything happens, this will become true. So I'm kind of skipping ahead here. So when this is true again, we are going to be calling s.replace, and we're replacing dots. But the interesting thing is this time there aren't any dots, so like there's nothing to replace. But this line does still get called, but it just doesn't change what s is. S is going to stay the same as what it was before. But remember, we're looping through the letters in R, so R still has that dot in it. And then we are going to go ahead and print S again. So basically we're just printing the exact same thing again. And then we're going to come back up here and we're going to keep going. So we go through the E, the D, the U, nothing happens until finally we get to the slash, and then something will happen again. So I'm just kind of skipping forward in time until we get to that slash. And then we're going to do s equals s.replace, and we're going to replace the slash with a space. Okay, so the last thing here is that s becomes www sus. Sorry, I have to move my hidden window so I can see this. CSCI-181-edu space. And that is the last thing that's going to get printed out. Okay. All right, let's go ahead and run this, make sure. Yep. All right. So, next problem. So we have a little beginning of a sonnet here by Shakespeare. Shall I compare thee to a summer's day? Thou art more lovely and more temperate. Rough winds do shake the darling buds of May, and summer's lease hath all too short a date. Okay, so we don't have any loops here at all. We're just given a few different commands here. So first, T is defined to be s.split, and we are splitting at the line break characters. So what's going to happen is s.split of \n is going to return a list that's going to have all the substrings between the line break characters. So the first thing in the list is going to be this line right here. The second thing in the list will be this line. The third thing will be this line. The fourth thing will be this line. So index 3 is going to be, so the first line will be index 0. This will be index 1, index 2. Index 3 is going to be this last line right here. And the thing that you're splitting at, whatever you put in the parentheses here, is never included in any of the substrings. So T is just going to be this substring. Okay, so that is going to get printed. So printed stuff. That's the first thing. And then what we're doing is we are then splitting T. So this time we're not putting anything in the parentheses. When you don't put anything in the parentheses, the split happens at any white space characters. So any spaces, any line breaks, any tabs, those are all used for the split. And we get back only a list of the substrings that were between white space characters. So this T.split here is going to be a list containing and then summers, and then lease, and then so on. And the index 1 is going to be, so and will be index 0, summers will be index 1. Right, so U is going to be summers. And that is the next thing that's going to get printed. And then finally here, V is going to be U.split M. So we're taking this U here, and we're splitting at the character M. So what we're going to get back is anything that was between M's. So there's SU and there's ER''S. I guess there might be some question in your mind of whether we get like an empty string back for being between these two M's, or whether we just get the SU and the ER''S. And the answer to that is I don't remember, and that's why I put 0. So you guys wouldn't have to remember either. So you get the thing that is before the first M, which is this SU part. Oh, we found SU in Shakespeare, huh? So V is going to be SU, and that is going to be the last thing that prints out. Okay, let's go ahead and run this, make sure. Yep. Okay, So last thing in this part here, A is the string how now, and we have a total of 0, so it looks like we're doing accumulator pattern. And we're doing 4 letter in A, total equals total plus A dot count letter. Okay, so that is a bit strange, but let's see what happens. So letter is going to go through each character in A, including the space, so not just the letters, but also the space. So the first value for letter will be the H, and then we're doing total equals total plus, so total is going to become 0 plus A dot count H. So we're going to the A string and we're counting how many H's are in it. There's 1, and that's what we're adding to the total there. So total becomes 1. And then we're printing out the new value for total. So printed stuff is 1. Okay. And then we're going to the next letter. So that is going to be O. And now we're going to total, and total is going to become 1 plus, that's the old value, plus we go to A and we count how many O's there were. And now there were 2 O's, right? So that's what's getting added to total. So total is now going to become 3. And that gets printed. And we go to the next character in how now, which is the W. And total is going to become 3 plus, and then we're counting how many W's there were. And there's 2 of them. Okay, so total is going to become 5 now, and we print it. Right, and we go to the next character, which is the space. So total is going to become 5 plus 1, because there's only 1 space. And then we're printing that. So we're going to print 6. Okay, and then we come to the next character, which is the N, and there's only 1 N, so this is going to be 6 plus 1, because there's only 1 N, so 7. So we're printing 7. Next character is the O again, so we're going to be adding 2 again. So total is going to be 7 plus the count of the O's, which is going to be 2. So that's going to be 9. So 9 is the next letter that prints. And then for the very last time it runs, the letter is W again. So we're going to have 9 plus the count of the W's, which is 2. So 11 is our last value for the total. All right, so we get 11. And let's check our output here. Yeah, 1, 3, 5, 6, 7, 9, 11. All right, that's it for this section. So we're at just about an hour here, so I'm going to stop the video here and I will resume in another video later on.